Yeah, we're live. Gonna fix my background here a little bit. There we go. And it's Friday night. Hopefully you guys are doing good. We already went out. So I'm back to do my video. Awesome stuff. Hopefully you guys got to see the video that I put up today on the tunnel ram stuff that we ran on the big stroker motor. It's a 468 cubic inch motor, 185 bore, and a 4.25 inch stroke. So it had a lot of both, a lot of bore and a lot of stroke. That's normally more stroke than we put in stuff, but we were able to sleeve the, it was an LS6 aluminum block, I think, that we sleeved. And Darton, the way back, I work with the guys from Darton, and they helped me sleeve it. And that allows us, because the sleeve length was much longer, it allowed us to put a 4.25 inch stroke in there. And then we were obviously able to bore it more as well, much more than you could on a factory LS6 block. So we were able to put that kind of displacement in it. And it was, because it was so much displacement, we used a flat top piston. We're able to run, you know, we were able to run obviously with a bore size like that. It's not quite, you know, it's bigger than a 4125. We've seen guys go 4200 or bigger. As a matter of fact, we made a 495 inch motor with a, I think that one was a 4.500 stroke on that thing, but it was also a tall deck block. So it was that one was an RHS block. This was just a sleeve standard deck block. But still, 468 inches, that was, you know, it helped us make quite a bit of power. Excuse me. In fact, we made way over 700 horsepower. As a matter of fact, way over 750 horsepower with the right combination. And we ran both LS7 heads on it and ported LS3 heads. On that particular motor, I ran a number of different things on it. We ran it a lot of different combinations. The interesting thing that I thought, and I did this both on the 468 and on the bigger 495, is we ran the factory intakes on them, and we tried the fast intake on there as well. And you saw in the video that those kind of both made the same power on that combination. And we see that a lot on the LS3 stuff, that the fast LS3 intake isn't really much of a gain, sometimes not any at all, compared to the factory intake manifold. And not because the fast isn't working, but the factory LS3 manifold is just so good. But on something with that displacement, and we saw that also on the bigger 495, that you know, the long runner stuff definitely is better down low, and that the single plane stuff, in typical fashion, we saw this on the LS3 videos, we're on the LS3 intake videos, and also on the cathedral port stuff to some extent. Although on the cathedral port stuff, the fast manifold is much better than the factory stuff. Excuse me. But on the LS3 stuff and on the LS7 stuff, the long runner stuff works well, but the short runner stuff, excuse me, is a little bit better, because it's everything that we're testing it on is so much bigger. Like on the LS7 stuff, it's at least going to be like a 427. And this one was a 468. Then we also ran on the 495. So on those bigger displacements, the short runner stuff can come into play, you know, a little bit earlier. But even then, even on the really big motors that are making lots of power, the long runner stuff still is just better down low through an awful lot of the curve. Not that anybody would be wanting to use a 12-to-1, 468 inch motor with that much camshaft in it for any kind of low speed power. You know, they're just not going to do that. But it's interesting that I liked how well the high rams did on that application. And I also thought it was cool that when we ran the comparison, that the carbureted stuff actually did better than the fuel injected stuff, because the carbureted one, and we see this a lot on a lot of different applications, even on single plane stuff, that the carburetor, because of charge cooling, typically makes more power on those carbureted applications, because you're injecting fuel down at the port, and there just isn't as much time for charge cooling to take effect. And it works very well with carburetors up there. And the question always is, yeah, but Richard, what about throttle body injection? Yeah, if you did throttle body injection, that would also help, because there's more time up there, because the throttle body is there where the carburetor is. But even then, I don't think it works as well. I'm not a big fan of those 4-hole throttle bodies that people put on there, especially the ones that are supposed to tune for themselves. I just have not seen that work nearly as well as a carburetor does, as a simple carburetor on a single plane or a dual plane manifold does. But that's another video for another time. On this one, excuse me, lots of running today. On the 468, these are bigger manifolds. Like we tested on the LS7 heads, we tested the big 4500 single plane CNC ported dual or 2-piece mast intake manifold, which if you kind of want to see what that does, this was the LS7 version, but we also ran the LS3 version. We also ran the cathedral port version in the respective intake manifold test. So you can certainly see what's going on with that manifold compared to the other stuff on the LS3 intake manifold test. But I know whenever we've tested it, the 4500 versions typically do better than the 4150 versions of those same manifolds. It just likes having the bigger carburetor on there, and likes having I think that kind of their wider spread too also helps with that intake manifold. Honestly, I think that the dual quad high ram typically does better than the single 4-barrel stuff does. I haven't tested all of them yet. I haven't tested the CID stuff and some of those things that I don't know if those were around or when I did my test, because some of those tests were done pretty far back. I don't know if they weren't around or I just didn't test them. I didn't have access to them when I did all of those tests. But the dual quad stuff is good because then you have a little bit better even distribution on the fuel, because you have carburetors over each one of them if you're running that carbureted. Obviously, if it's injected, and the one that we used was actually injected, all we did was just keep the injector holes plugged with injectors in it. So that was very simple to do. But the high ram stuff is good for those kinds of applications, and it worked better with the carburetor, as I said. The interesting thing is that I get a lot of comments about, well, okay, why don't you do a blow-through setup with turbos or blower or something blowing into, 2 carburetors on top of a high ram? And I've never tried that. And we know that it would work as long as you could get even airflow distribution to both of those carburetors. And then both of those carburetors would need to be blow-through carburetors, and then you could make it work. There to be a little bit more tuning involved for something like that, because you'd have to either use twin turbos or twin blowers, and then twin hats on each one of them, or a common a large common plenum hat kind of that goes over both of them, and then feed that with a single big turbo or single big blower, or 2 of them with 2 inlets somewhere in that. And that all of that's doable. It might be more of a gee whiz thing, because we've seen a run at West Tech where, like Mike Miller, that is a real engine builder and has done these kinds of race motors with, when they go up pretty far in power, he ends up using a blow-through Dominator size carburetor, and then blowing into it with a some kind of big centrifugal like a Vortec or something. But stuff that's in the 1500 to 2000 or more horsepower range, that's typically what they do, and they can do that with a single carburetor. Because the thing is, when you're blowing through that, just like with throttle body size, that the opening size and the flow rate of that throttle body becomes less critical when you're pressurizing it, because the flow rate of the orifice goes up dramatically. So as long as you can get all the air in, but as long as you can get the commensurate amount of fuel with it, and on these blow through things, you typically can do that. And if you're wanting to make 1500 or 1800 or 2000 or 2500 or whatever, you can certainly do that on blow through applications. I just have never tried it with 2 carburetors. Obviously, the higher ram is very popular for drag racing guys running it as a blow through, usually with EFI and a single front mounted throttle body is the way that they typically do it on LS stuff. So whether they're blowing through with a single turbo or twin turbos, or centrifugal blower, a Pro Charger, those kinds of things, that's done all the time, and it works pretty well. They just use the injectors in their conventional positions, and that works good. I haven't seen too many people change injector position on those, but you certainly could if you raise the injectors up farther in the runner and introduce the fuel earlier. Then you could get even more charge cooling and probably make a little bit more power. Be interesting to see. One of the things I always wanted to do that I talked to Brian Tooley about is we wanted to make an intermediate plate. And I think that they've done this now with nitrous. We want to make an intermediate plate to position the injectors inside the plenum of a high ram, kind of the way that they do by sandwiching an intercooler in there, we wanted to sandwich the injectors in there and then run, if you ran E85 and you're blowing the injectors in the top of the runners, kind of like you would with introducing the fuel there for the carburetor, but just do it in injected form. And then that way, and especially if you did it with 8 injectors, then you have the full tuning and you have the extra fuel, the charge cooling. So you kind of have everything. And we just never went through all the trouble to make all of that happen. I kind of had that thing drawn up on, cocktail napkin at some point and said, hey, look, this is what we should do. And we both agree that, hey, yeah, this would be kind of cool. Be interesting to put E85 through it in that kind of configuration. You wouldn't need a sandwiched intercooler. You could still run an intercooler before the throttle opening, but it just introduced the fuel higher up. But we've done that on Bonneville cars and stuff, and it definitely works. So we kind of wanted to try that on a higher end because it's easy to do because you can sandwich everything. So if you just made a centerpiece that housed the injectors and held the rail, and you have external inlets and outlets, and all of that is really doable. So that kind of would have been a fun gee-whiz thing. And we know that repositioning the injectors up higher, even on the outside, but on the inside, it would be, it would be kind of cool. So that would all be cool stuff. So we'll get to your guys' questions. It's Friday night. I know everybody has a lot of stuff to do, including me. Let's see what you guys got going on. Who's a young man in the thumbnail? Exactly. Yeah. Sleeving the LS was kind of pricey. The Dart, I can't remember now what the Dart and stuff cost. This one was done quite a while ago. Have you ever done any testing on a Mazda Speed 2.3? I have not. We've done some stuff. I've done some stuff on the chassis dyno where we ran those motors and they did intercooler upgrades on them and turbo upgrades and those kinds of things, but not on the engine dyno. What do you think about boring out injectors? If you're talking about decapping them, which is very common with injectors to increase the flow rate, we've done this years and years ago. The guys at Steve from Powertrain Dynamics did it with, I think we had 36-pound injectors that he turned into, I think that they were 72s or 80s or something like that. The problem with decapping the injectors is that you definitely need to reflow them after you do that, because they don't seem to all come out even. So if they're even to begin with, and then you decap them, a lot of times the flow rate after that is not the same. So it's certainly possible to increase the flow rate. You change the pattern also, but also, like I said, sometimes they're not all even. So you make sure you check that if you do it. Let's see. I'm a fan of throttle body injection and central fuel injection. Carburetor TV down, ignition signal or map sensor lost. HOLLEY, if I don't understand for a Duraspark. It's more than that, Dean. They don't seem to be repeatable, and they don't seem to have the same kind of distribution that carburetors do. So you can get those systems to work sometimes not with a single plane, and then sometimes not with a dual plane. They just don't adapt the way that a carburetor does. And they tried, and they know that. They've worked on them. All of the people that were doing them have worked on them. They've tried having the injection above the throttle blade, below the throttle blade, all kinds of stuff. So it's not that I just don't like them. There are issues. Can I bore my L83 to fit an L86 piston? I don't know. I don't know how big the sleeve is on the L83. What are you doing more stuff on the L67? I haven't done anything on an L67 for 10 or 15 years. If you're talking about the L32, we're going to do another one of those. Yeah, secondary injectors or injector placement is good, Dean. Obviously, if you look at the video that I did on the stack injection on the Honda and putting the injectors out in front of the air horns, definitely made more power. That's how I was able to get more than 200 of the tire out of a little B16, and that worked very well. And I made the slider assembly so that we could change the distance of the injector away from the stack from the air horn, because I was worried. I was a little concerned about airflow when we were putting the injectors out in front. As it turned out, that didn't really affect airflow very much. I think long tube EFI individual throttle bodies under a single or dual plenums would be the bomb. When you make a common plenum with individual throttle bodies, then it just becomes a standard manifold. It doesn't matter that there are individual butterflies there. It's not an IR manifold anymore. It's just a common plenum manifold with that runner length. Yeah, Shane, you could do dual injection. If you have two fuel systems, you could run one kind of fuel through one of them and a different fuel switch over to those. The one that we did, that Tom, the guy that used to work at West Tech, we did stage injection on one of the motors that we did for Bonneville. And we did it so that we can move the injector higher up. And so we could get additional power from the motor, because it really wasn't making very much NA power. We are going to do more testing on the K24. We're going to do a big bang on it. So Myers, do they not have an L32 and an L67 designation in Australia? Are they all the same? Is it not a Gen 2 or Series 3, Series 2 and a Series 3 motor? What are the benefits of tubular Shorty headers compared to factory cast iron manifolds for turbos running over 900 wheel horsepower? I don't think you'd see very much. I don't know. You'd have to check the flow rate of a Shorty header versus a set of stock cast iron manifolds. My opinion is that your flow problem is not going to be the manifolds. It's almost always going to be the turbo. Yeah, Mike, we've used steel tubing, aluminum tubing. I've used tape to tape them together. On the Hemi, I just slid the tubes in and let them sit there. We eventually had to kind of clamp them in place. It's easy to check runner length. It's not really critical how you connect them together. Radiator hose works good, as long as you don't want a radiator hose with an end like that, or some sort of radius to entry, or even a flare on it is really good. That's why when I do the adjustable manifolds, I just go to the muffler shop and I have them just swedge the end of a bunch of tubes, and those are my radius entries. It doesn't have to be a full 180-degree radius or whatever. It doesn't have to be like that. You can get, with just a flare on it, you can get about 90 or 95% of what a full radius air horn does with just a flare on it. It's a big change in the flow rate of the tube, rather than just having a flat edge. Things that you find out when you're on the flow bench. Definitely need to see some content on the GM direct injected stuff. We've done some L83 stuff and some L86 and some LT1 stuff. We're going to do more when I go back and see Brian. Mr. Flimflam, thank you very much. Boost Kaboom, what kind of a loaded question for a Gen 6 454? So you made a 496 out of it. Do you think the stock heads are still sufficient as far as airflow? Pump gas mild cam. You're going to get a lot more power, obviously, if you want more power out of a set of aluminum heads. The problem that you have, if you're going to a 496, you've kind of solved part of the problem, and that's that the stock heads have really, really small chambers on the 496. They're like 102 cc chambers. So it's really hard for you to find an aftermarket set of heads that are that small. So when you do a head upgrade, and I have these videos up, like we put a set of Brodex heads on, which helped power, but they lose power down low because they drop static compression so much. On a 496, you put a flat top in it, and then you've cured that, because you can combine the flat top with a bigger chamber in an aftermarket head and get the same compression or more compression than you had with the 454. So any sort of good aluminum head is going to make more power than the stock head is. But if you're only putting a 206, 212 camshaft in it, it's kind of irrelevant, and you don't need to do it. What's the best rear gear ratio for a boosted LS? I don't know what you're trying to do. If you really want to get into gearing, you need to look at gearing versus trap speed, if that's what you're trying to do. If you're not doing that, then almost any gear you have in there, any sort of 3 Series gear in the rear end is going to work good with a boosted motor. On factory TBA, Nissan V6s and Fords use Tubular Weber 38 style. So you're talking about bias for the fuel entry? Can you use factory heads of an L92 and doing an LS9 cam swap? Yes, you can. Maybe stupid question. No, there's no stupid questions. There's only questions. How much power can you get using stock injectors for an LS3? I think a stock is, somebody maybe correct me, but I think a stock injector for an LS3 is about a 42 to 46 pounder. So 90 times 8. So it's going to be less than 600 horsepower on an NA motor, and not with E85, only with gasoline. So if you're trying to make 600 horsepower, you need to upgrade those injectors. Here in Australia, the L32 is an NA version of the L67. I thought that was an L36. At least that's what it is here in the States. I just saw this one. I just came here to point out that the LS4 intake would probably dominate a tunnel ram. Yeah. How about no? So I can go back while we're waiting for more questions to show up. Texas is in the house. Your Nova's coming along. That's good. We're live. I'm assuming this is what are the best heads to run on a 6-liter. Normally, it's the ones that came with a 6-liter, but it's going to depend on what you're doing. If you're trying to turbocharge it, you can run the stock heads, which is going to be a 317 normally on a 6-liter, unless it's a 6-liter LY6 or something. Then it's going to be a rec port head. But even those will work good. Let's see. The Trailblazer SS intake works good. On my mildly cam 5.3, I had an oil pressure issue and ended up installing a Mellings high volume, high pressure pump. It runs 110 PSI. Yeah, that's way more than you need. You'd at that pressure, you have to watch for maybe damaging and exploding the filter. I remember your contributions to Muscle Mustangs and Fast Forwards, Vinny and Evan, yep, and Campy. What are the benefits and trade-offs of stroking versus de-stroking an engine for boost? I think that's the wrong question. I think the way you should approach making power with boost is, how much power do I want to make? And then you pick the turbo to do that. And then your engine will probably do that with that turbo. If you stroke it, you'll do it with less boost, but the turbo is still going to dictate how much power it makes. If you de-stroke it, it's going to take more boost to do that because it's a smaller motor. So there's no inherent benefit from either one of those things, other than if you make a stroker motor, it's going to make more NA power. So that's going to make more power at any given boost level under boost. But the big question is, how much power do you want to make? If you pick a 700 horsepower turbo, either one of any of the three, a standard displacement, a de-stroke, or a stroke motor, is only going to make 700 horsepower. If you're wanting to make, 2,000 horsepower, then there's another thing to think about. but most guys are not in that. Most guys are not trying to do that. Do you think a carb spacer plate drilled out to hold injectors would work? There's not spraying in the right direction, in my opinion. I've heard the dormant LS2 is comparable to an old fast 90. That's not true. It doesn't. A dormant LS2 doesn't make the same power as that fast does. As a matter of fact, I don't think the dormant LS2 even makes as much power as the fast 78 millimeter. So there's this myth that the dormant LS2 is a copy of the fast, and that's not true. At least not compared to the testing that I did. It doesn't do what those do. It does do the dormant LS2 does what excuse me, what a Trailblazer SS does in terms of power. Stock bottom end 5.3, twin 6762s. That's enough to support 1,000 horsepower. Have an LS1 cam. If you're trying to do 1,000 horsepower, those turbos will do that, and they will do it with an LS1 cam, but it's going to take a pretty fair bit of boost. That's not a great cam, but it will work. Take a look at the video that I have up. We ran the LS1 cam and all of the other factory cams as well. When running a supercharger and a turbocharger at the same time, is it worth the amount of boost versus money? Probably not. It's cool, but you can just usually get what you need with the turbo. 4.8 4.8 liter is a good first boosted motor. A Billet 7875 from Monkey Fab. Those are good turbos. You just put a high compression ported 462 valve together. Good. Would the slant 6 hyperpack intake be considered a tunnel ram? I don't know that you could. I don't know if I would consider something a tunnel ram for a inline 6-cylinder, just because it comes from the side. So I don't know that I think that the slant 6 hyperpack deal is kind of more of just a long runner manifold. Power Nation did a turbo 300 inline 4. I saw that, and I think that they made about 500 horsepower with a turbo, which is certainly easily doable. The 102 millimeter throttle body flows 1500 CFM. Kevin, would you build a 5.7 LS1 with Gen 4 5.3 crank and rods and Summit forged pistons? You can. The LS1 shares the same crank and shares the same rods. The Gen 4 rods are going to be better. The crank is not going to change at all, and forged pistons would help. I don't know if you're doing a turbo one. If you're doing a turbo one, I wouldn't pick a 5.7 LS1 block to do that with. Lost in a sea of bearings, bimetal, tri-metal bearings at OEM. Well, given how much power we've made with junkyard LS applications with factory bearings, I would say they work just fine. And usually if you lose a bearing, it's not because of the bearing metallurgy or the makeup. It's usually a lack of oil is the problem. Edward, I've never seen any definitive spool tests on journal bearing versus ball bearing. Once you have oil, there's not really, I don't know that there's any contact, and I don't know how you would get enough change in friction alone to see a change in spool rate. Spool rate, in my opinion, is way more affected by low speed power output and stuff than it is by the bearing type. Will you be testing the China GT45 at 60? I don't have anything to run 1600 horsepower on right now. So you want to make 450 horsepower from a small block Chevy. I'm assuming it's a 350. So you're going to need a good head and lots of camshaft. An AFR head's really good. Trick Flow has lots of good. There are lots of good small block Chevy heads for it. The better the head is, the easier it'll be for you to achieve your thing. You're going to need a camshaft that's going to be like at least 230 at 50 on the intake. And then you're also going to need probably roller rockers. You might be able to do that with a dual plane, but like an RPM air gap and a 750. When do you start entertaining the idea of O-ringing over MLS? I wouldn't O-ring anything that I build, because if we've already done more than 1,500 horsepower with MLS gaskets, and I don't think we were anywhere near the limit of the MLS gaskets on that combination. So I don't know where that would be. It would not be in an area that I would be in. Bearings on the 4.8. Different kinds of bearing test. That's not something that would ever happen. Just put bearings in it. There just needs to be bearings there, and they need to have oil in them. You're not going to ever see any change in bearings. Nothing that I could test anyway. Half fast. Thank you very much. Have some refreshments. Yes. Raspberry lemon drops. That's my jams. Ordered an S372 SXE with a 1.27. That's a big housing for my heads cam 5.3 9F 1 crush. The AR is fine. The 372 is not a very big turbo, so it depends on how much power you're trying to make. But the SXE family is really good, though. What's the most horsepower you got out of an L92? I've never tried to max out an L92 engine. We only did that to the LY6, which is an iron block. And so we don't normally do those aluminum blocks. So an LS3, an LS2, an L92. An L92 is an aluminum block motor, right? I think it is. And so that's normally 1,000 horsepower to 1,100 horsepower, right in that range is where we kind of stop. Do they make camshafts for the Nissan Patrol, the 4800? I'm not familiar with that engine family. I mean, not from an aftermarket standpoint. The Boss 302 intake, they don't love boost. The Boss 302 intake likes a specific engine speed, and I have tested the Boss 302 versus the other intakes, the factory intake, and different kinds of intakes. And intake manifolds, all intake manifolds want to be effective in a given RPM range based on their runner length and design, and the Boss 302 is no exception. And then you can just add boost to that. Wheel speed sensor data on the BorgWarner show ball bearings get this higher speed faster than journal bearings, but turbine wheel speed doesn't exactly equate to power spool. So you're saying that the wheel spins up faster, but then that doesn't equate to boost coming on sooner? Have you done any testing on pre-Magnum LAs with roller cams? I have not. That's kind of a real specific thing. I've only ever built one LA motor, and I didn't even build it. It was already built. It was in my van running, and all I did was take it apart, and we didn't even take it all the way apart. All I did was put heads, cam, and intake and that kind of stuff on there. So I don't have a lot of pre-Magnum experience, and certainly not. The only one that I did was flat tap and stuff. It was real early on. It wasn't during the transition where they went at the end of the LA era, right before they switched over to Magnums, when they were running hydraulic roller stuff. Okay, 800 wheel horsepower with the S30. 372. And you, Brett, you've no doubt looked at the map on that. Bobby, thank you very much. Big baby L99. Actually, the L99 does need to happen, but what even more needs to happen is everybody wants to see the DZ302 version of the L99 and LT1 hybrid. You should test the HOLLEY Ultra Low Ram versus the BTR Trinity on their Equalizer 3 or their Equalizer 3 intake. The problem with that is I don't have a motor that would need to run that would go to 8,500 RPM that you would use either one of those manifolds. They're both very, very short runners. They're only about 4 inches, so they're going to want to make power really, really high. On today's Tesla numbers you gained were excellent, and torque numbers seem strong. I thought some of that. I don't know what you mean. The gains that we got had nothing to do with the camshaft because the only things that we changed were the intakes. Do you plan on doing any more water meth injection? Yeah, I actually wanted to do water meth injection on the 3800 supercharged motor because I think it's a really good application for that. Yeah, Mopar guys, especially early Mopar guys, get mad when you tell them how much better the Magnum is than the LA motor. It's a new generation. Of course it is. What's next on the Big Bang list? Well, we still have yet to do the K24, obviously, and we need to do the 3800. I don't know about O-ringing a block because I haven't ever done it. If you're doing a 523 big block Ford and you only have lightly ported EFI heads on it, you shouldn't worry about O-ringing it. An MLS head gasket is going to make the power that you're going to want to make out of something like that. Because if you have enough clamping force and you have enough deck thickness to where the deck is not distorting or you're not lifting the head, then if you damage an MLS gasket, you damage something else. You damage the head, you damage the block, you damage the piston. My Duramax intercooler setup on an LQ4 with an 80-103 seems like it might be limiting. I know a 7 PSI drop across the intercooler core is definitely a problem. Yeah, Mike, I don't have a motor right now that can handle that turbo. That's a lot of turbo. S4, I would be worried about a 7 PSI drop across the core. It's obviously making the turbo work harder. That Duramax was not designed to flow the amount of air that you're flowing with that turbo, because it was designed to flow a lot less airflow on a diesel application where it's making maybe lots of pressure but not lots of power. So the flow rate is why you're seeing a big drop. It wasn't designed to flow the kind of stuff you're flowing. You should stack 2 of them together or just get a better one. Ooh, a turbo Ls Subaru, that'll be cool. I put my email usually every night. Uh, 11 to 1, and you're going to turbo it. You're going to have lots of octane, and E85 would be good. And you're going to have the right tune and an intercooler and all that. 240Z trying to get it in the 4s. That's pretty sporty. Yeah, Jay, there's nothing that a Mopar guy, like an LA guy that's a 318 or 360 guy, even a 340, they don't really have a good head to reach back and go, oh, this one was good. Because even the 6-pack head or the J head or the X head, none of those were good. Those were like a guy saying that a Fuley head is good on a small block Chevy. You know, they worked back in the day, and I don't want to disrespect all the Fuley guys or even the 340 guys, but they're substandard heads compared to what we have now. I mean, any 5-liter or 5.3 liter junkyard head flows way more than all of those heads. And that's something you go get for next to nothing. Thoughts on water meth with turbo using Super Sniper EFI? I don't know what Super Sniper EFI is. A lot of guys want to run water meth before the turbo. I'm not a fan of that for longevity. I don't think injecting it in front of the turbo helps with distribution, because and especially if you have an intercooler between the turbo and the manifold, and then you have a long runner manifold, I don't think that any sort of improvement that you might get with atomization because it went through the spinny blades is going to do anything. Because I think you're still going to run into the same distribution problems. I've been playing with my 350 small block. I'm working on making it more efficient. You can do lots and lots, and guys have been doing lots and lots of small block Chevys for a lot of years, or you can swap it. And swapping it obviously is a lot more involved. How good is the PRC 225 heads on an LQ4 with a Pro Charger? They will be a 225 head. Almost any 225 head is enough for you to max out that Pro Charger. If it's a D1SC or an F1A94, you could get everything out of that supercharger with that kind of head and a good cam on an LQ4. .430 bore, 331 ring gap, 10 pounds boost. We use a calculator for the street. It tells me 21 top and 24. When you use a calculator to get, how do you get 21? How do you get a gap of 21 with a 4-inch bore? It should be a minimum of 6, and we like to go 7, so you'd be closer to 28. The angle plug bow tie heads, but that's not a factory head though. Mopar guys do have W2 and modified engine quest heads. Again, none of those are factory heads though. So that's like saying that there are good aftermarket heads for Mopars, which there are, and there are good aftermarket heads for small block Chevys, which there are, and good aftermarket heads for small block Fords, which there are. But like with a small block Ford, there's not a good factory small block head unless it's a Cleveland. None of even a 69 351 head, that's not a great head. I mean, not compared to any sort of aftermarket head, and certainly not compared to a Cleveland. There's nothing that's going to flow. You know, no 351 Windsor head is going to be anywhere near flowing. I think when I flowed the Boss heads, I think that they were like 275, which is quite a bit. S4, no problem. Yeah, I think you're looking at a flow rate problem. Are you going to swap the C4 Vet? An LT1 is definitely going to make more power, although you may have trouble with the ignition system in that. A C4 Corvette, for all intents and purposes, is just a small block. You could get rid of the tune port stuff and just put a carburetor on it, and it would be lots more powerful. I don't know what you're doing or where you're driving it around, though. The nice thing about the factory intercoolers on those Duramaxes and stuff is that they were cheap. I run direct injection meth with a 9th injector post turbo, stays below 110 inlet air temp, seems to work well. Yeah, you can get, if you measure the inlet temp in the common plummet of intake manifold, you can get fairly good charge temperature readings, but the problem is it doing that in every one of the cylinders? And is it given not just the air temperature changes, are we getting the amount of extra fuel or octane or whatever it is you're looking for from the water meth in a long runner manifold? So Kevin, you have a 2,800 pound car. It's an 1/8 mile car. 1,000 horsepower is really easy with a junkyard turbo LS. So that's probably the least expensive way to go. 20 miles per gallon. That's pretty good. I've got an LM7 trying to make a decision between turbo and procharger. Matthew, take a look at the video that I have of comparing a procharger to a turbo, and you'll see there's a big difference in the excuse me. There's a big difference in their boost delivery. A centrifugal blower like a procharger or Vortec or any of those centrifugal blowers, Torque Storm, it's going to have low boost at the bottom, and it's going to climb until, and the peak boost is going to happen at peak engine speed. Turbos are going to have a lot more average power production because they're going to come up to, especially if you have a good wastegate, they're going to come up to boost, full boost a lot sooner, and then they're just going to carry whatever that peak is across. So you'll make a lot more average power with a turbo than you will with a procharger, if that helps you out. If you're running a blow-through carb hat deal and some sort of blow-through, even if it's an EFI deal, you're going to get charge cooling from that, which will be beneficial. And then additional intercooling or additional charge cooling from the water meth will help. Are you blowing into a single plane intake manifold? If you are, that will be probably the distribution issue will be less prevalent on that kind of manifold. I have a high ram portable benefit on LQ9. Well, you saw what happened when we were comparing the high ram versus the long runner stuff. Typically for stuff that's less than 6,500 RPM, a high ram is not the way to go, especially on just a 6-liter. On a turbo engine, does long runners make the turbo boost sooner? Yes, it does. And the reason that it does that has nothing to do with turbos. It has everything to do with long runners are designed to make power earlier in the RPM range. Long runners add torque down low. And when I say down low, I don't want you to think they, whatever your definition of long runner is, and it adds it at 2,000 RPM. You saw that the fast manifold makes good power, or the factory LS3 manifold or Trailblazer SS or any of the factory style long runner manifolds make good power all the way up to about 6,500 RPM. When you put something shorter on, like a single plane or a high ram or the Sniper kind of intake manifolds, the fabricated ones with shorter runners, they will lose a bunch of low speed power. So if you have more power down low with these long runner manifolds, you'll get boost sooner. Yeah, if you can get a 6-liter instead of a 4.8 or a 5.3, it will make more power starting out with. Referring to your video on maxing out the GT35, I think we maxed out the GT45, not a 35. The high torque horsepower at low RPM running out at high RPM, does that not mimic what the factory motors choose to do? They do that. They do that by design. They have a falling boost curve, and they will eventually do that just because of turbo sizing ultimately. But usually when they pick a turbo, they pick a turbo that has some left in reserve. It's not maxed out on the factory power rating. So they could make more power, and they could produce, if they wanted to, some sort of flat curve at some given power level, power and boost level. But ultimately, the small turbo is going to do that. It will be able to make a lot of power down low, but it won't be able to sustain that at higher RPM. Where you like to measure coolant pressure and oil pressure. We don't usually measure coolant pressure on the dyno, but oil pressure, we measure it. We take it off of the oil pressure sending unit on the back. We remove that and just put a fitting and then run a hard line over to the dyno. Which cylinder head would you recommend for an LA motor? I don't know. I don't have a lot of experience with the LA motor. We've run Elbrock stuff. Almost everything that you put on there is going to need to be ported. Maybe a W2. Anything ported by Dulcich would probably work really well. Dean, I don't think that an X or J head flows 235. Kevin, thank you very much. Maybe a W2 does. Thank you very much, Kevin. Bring the 30-inch runner back. Yeah, that's what we all need is 3 feet of runner length. And I've done stuff like that. I don't know if I've gone all the way to 30 though on some of my adjustable stuff. But they have run one of the Sonoramic deals on at West Tech with 2 carburetors on it. It was pretty cool to see the fuel stand off above the carburetors. Aftermarket heads on a 351 turbo would be the way to go. A Cleveland head's not, it flows a lot for a factory head, but it has a really big port. It has a poor exhaust port. So it's not optimum for, it's not anything that I would compare to an aftermarket, inline head. Blow through on big block Chevy cross ram. Yeah, if you can make it a direct port deal on water meth, that we know that you get even distribution there. Have you done any hot side piping with harsh angles? I have a lot of, when we run this up on the dyno, we put a lot of 90-degree turns in it, but they're usually mandrel bends, though they're not usually sharp turns. Danny, if it's a K24 or K20, a GT3076 probably would be good for that range. Yeah, you're going to want to port the exhaust ports on the GT40 heads as well. Yeah, you can do 30-inch runners on a slant 6 because we have lots of room out there. I could also do that on the manifold that I made for the 4200. An LQ9 with 243 heads and a high ram. It's a good start to make NA power. You're going to want to. That's not the intake I would pick for that combination unless you're trying to really drag race it. You'd be much better off with the factory manifold that was on that combination, a truck manifold or a Trailblazer SS. But you want a cam like the Comp 459 or the 469 cam, something that's 231, 247 kind of thing. What oil pressure do you try to maintain? We don't have a set value. The oil pressure is going to be a function of our oil temperature, the oil that we started with, whatever condition our junkyard motor was at. We don't change oil pumps on them. And then if we're taking the feed for the turbo off of the first position, which is in the very front of the block, you're going to lose more oil pressure there than you will if you take it farther back. So we just let the chips fall where they may. No, Scott, we reuse MLS gaskets. Holley E5 versus Fast X5 for boosted smaller port. I like the Holley. Yeah, we've used Fast a lot, and it's kind of what I learned on. But the Holley, I think, is more user friendly. Somebody let him know what you're looking for. A Vortec head casting. You just got to look and make sure that it's not cracked. But I think the 906 is what people get. How much boost can I run on an engine with approximately some displacement stock heads? So mild. Just tell me what motor you have and then how much power you want to make, and we can kind of give you an idea. Yeah, Urson cams were big back in the what was a big speed shop back in the day that had all the Urson cams? 906 or an 062 for the L31. .62 cam only versus 60408 stroker. What you want to see, a competition between those two, or super shops? That's what I was trying to think of. So did they have different cores for their castings down in Mexico when they were doing them? Super shops, $39.95, complete with the nuts, bolts, and gaskets. Yeah, Casey, everybody likes it. As a matter of fact, I just had to, somebody on Instagram was using the footage, and I'm sure a lot of people are, that I've never even tried to go after anybody, but somebody was using the footage from the explosion from the nitrous stuff, and the guy was using it, and he was crediting somebody else for it. So that guy that he got it from, this guy, I talked to him and said, look, that's mine, and I'm happy to share it, but at least I should get credit for you guys stealing my stuff. And I don't know who the first guy was, but he obviously pirated it too. Yeah, the 302 blocks were definitely stouter. What's the highest NA horsepower you've seen from a Gen 3 or 4 stock bottom end with an OEM head? Can the OEM head be ported? Matthew, you got to tell me what you're trying to do with those heads. The 799 heads can make a lot of power. They can make more than 1,000 horsepower if you have a turbo on it. So if in that case, you don't need to change them. If you're trying to make a lot of NA power, a ported head is a good way to go. Okay, Daly, I didn't understand what you were trying to ask. A 6.0 with 799 heads and a stage 3 cam will not make 550 horsepower, Mike. You can do that with a ported set of heads or or maybe a factory LS3 head, but not with a 799 head. Yeah, TrickFlow has really good, their 205 heads for the small bore stuff are really good. Yeah, ultimately you would be limited by the power output, by the flow rate of that stock head. They're going to limit you in power because they don't flow a ton. We've made over 500 horsepower with a stock head on a 6-liter, on a cam 6-liter. I have done testing on the CHI 3V Cleveland heads. I did a bunch of testing with them way back. The LS3 head will support, we've made almost 700 horsepower with with a factory LS3 head. So it will support a lot of power. That was on a really big motor, but they flow 315 CFM. So it's pretty easy to see what kind of power they would support if you have enough motor underneath it. The Ollie with the EQ heads are a cast iron replacement for the I'm sure Dean is probably talking about the EQ replacement heads for the LA stuff. Ported A23 heads, you know, are going to flow 350 or 360, so you can make a lot. The problem usually isn't how much power you can make with the head, it's having enough motor underneath that, because they'll support 750 horsepower or more. Mike, that's what I'm talking about. We made almost 700 horsepower with a stock LS3 head. It was on a big motor, but that's what they'll support. They flow 315 CFM, so we know that they'll support way over 600 horsepower. In our case, we got almost to 7 because we had so much motor underneath it. Jay, I didn't compare the CHI heads to any of the aftermarket stuff. We just built some stuff with the CHI heads. And I think I used the CHI heads on either the Boss 351 or the Boss 302 or something. I think on the Boss 302. Yeah, S4 we made almost 700 with a stock LS3 head, but it was on a 495. Can a pair of 243 heads make 1,000 horsepower? Yes, very easily. A 706 heads can easily do that. Yeah, S4 was a 495, and if you look, you'll see the you should be able to see the test. Look at the LS3 head test and look at the LS7 head test. So 3rd gen, you have lots of L76s and LY6s out there? Dude, I need to come visit. Jay, so you want to control the wastegate to limit torque production and control the boost curve. That's just having your boost controller. You have to have an electronic controller for that, and it has to be referenced to RPM. So you're going to open it more at lower engine speeds and then close it as you get higher. Yeah, the LS7 heads are good, but the thing is, the a lot of the LS3 heads that we had flowed as much as the ported LS7 heads did. Giovanni, you don't need to put a direct port nitrous system on a stock 5.7 Hemi. That's probably not a good idea, because you have to run really, really small jets to run a realistic amount of nitrous that a stock Hemi would work with. If you're gonna run a lot of nitrous, you should do ring gap in it, and you should do head studs and good gaskets on it. You probably can inject enough nitrous into a factory manifold. I think we run 150 shots on those just with a single fogger in front of the throttle body. Dirty, I'm not going to retest that, because this Tesla's run, I don't know, 10 or 15 years ago. But just look at the LS3 test and look at the difference between a high ram and the single 4-barrel. The high ram makes more average power than the single 4-barrel does. I have an LQ4 with a 76mm turbo, fast, 317s, car made 850 with another set of heads. No, they wouldn't have been any benefit to you, because that's not what's holding it back. The turbo is ultimately limiting you, not the heads. Yeah, the BMW motors would be cool. Put a smaller intake valve on the LS7 head. The chamber diameter is bigger on the LS7 head too, not just the valve. It has to be for the valve, so you're gonna have overhang on the chamber. And then I think to put a smaller valve in it, wouldn't you have to change the seat also? You're gonna do an update video to the rear mount turbos. What else did I need to do on the rear mount stuff? Okay, one more question. I gotta get going, guys. It's been an hour and 7. Daily, thank you very much. Can you recommend, this will be the last question, Daily. Can you recommend an RPM range that I should limit boost on an early B-headed 4.6 valve? I like to avoid killing the motor with torque. I don't think you have to worry about that. I don't know how much power you're trying to make with that, but it's going to be limited all on its own, because it's not going to be real responsive anyway. You can also do that with turbo sizing. Like if you have a turbo that you put, if it's a single or twins, and you make them slightly oversized, they'll be soft down low, and you won't have to artificially limit that. So they won't come up until later in the RPM range, and then you have all the boost where you want it, where you want to have it. Texted block, factory heads, cams, internals, ARP rod bolts, ARP head studs, MLS gaskets, and you did ring gap. So you're probably good. And how much power are you trying to make with that, Daily? I mean, if you're only trying to make 700 horsepower or something, I think you're probably golden. As much as the GT45 can give me without throwing rods out the bottom end, the GT45 is going to be like a 700 or 750 horsepower turbo, probably on that motor. It's going to be a little soft, because that motor is not going to make good low speed power. So honestly, I think you're going to be fine. And if you have to, you can also take timing out there too. So I think you're going to be okay. I'm not sure if this has been asked, but the latest Engine Masters episode. I haven't seen the latest Engine Masters episode, so I don't know what you're talking about. Yep, no shortage of testing. So I got to get going, guys. Thank you all for showing up, and I will see you all tomorrow. Do, 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 do.